Every morning, the sun rises and brings our world to life. Its light travels millions of kilometers, ending the darkness and warming the Earth. The sun is the center of our solar system and the reason life exists here. Every plant, animal, and human owes its existence to this glowing ball of gas. Without the sun, Earth would be a frozen, lifeless world. The sun's gravity holds the solar system together, keeping Earth and the other planets in orbit. Without it, we'd drift into the cold void of space. The sun is our anchor in the cosmos, a constant guide on our journey through space. The light you see began its journey from the sun just over 8 minutes ago. That energy was created deep within the sun's core thousands of years before. We live in the light of an ancient fire that has burned for billions of years. Its story is our story. Understanding the sun's journey from its fiery birth to its eventual quiet death helps us understand our own place in the universe. The sun is not just a light in the sky, it is the engine of our world. Its energy and gravity make life possible. When we look up, we're seeing the source of everything we know. The sun's epic journey is deeply connected to our own. Many think the sun is a giant ball of fire, but it's not burning like a log in a fireplace. There's no oxygen in space. Instead, the sun's energy comes from nuclear fusion deep in its core. In the sun's center, pressure and temperature are so extreme that hydrogen atoms fuse to form helium. This process releases a tremendous amount of energy. When 4 hydrogen atoms fuse into 1 helium atom, a tiny bit of mass is lost and turned into pure energy. Einstein's E=mc2 in action. The sun performs this reaction billions of times every second. The energy produced pushes outward, balancing the inward pull of gravity. This balance keeps the sun stable and prevents it from collapsing. The sun is a controlled, self-regulating nuclear reactor, not a chaotic explosion. Its steady nuclear heartbeat has powered life on Earth for billions of years. Gravity tries to crush the sun, but fusion pushes back. This equilibrium is why the sun shines so reliably. The sun's stability is the foundation of life on Earth. Its energy is the reason we're here to wonder about it. The sun's nuclear heart beats on, giving us light and warmth. The sun, like all stars, has a lifespan. It was born about 4.6 billion years ago from a swirling cloud of gas and dust. Gravity pulled this material together until nuclear fusion ignited in the core. A star was born. For billions of years, the sun has been in its most stable phase, called the main sequence. During this time, it steadily fuses hydrogen into helium, providing the energy for life on Earth. This long period of stability allowed oceans to form and life to evolve. But the sun's fuel isn't infinite. It's about halfway through its main sequence life, with another 5 billion years to go. After that, the sun's story will change dramatically. When the hydrogen runs out, the balance between gravity and energy will break. The sun will leave the main sequence and begin its final transformation. It will swell and become a different kind of star. This marks the beginning of the end for our solar system as we know it. The sun's life is a slow cosmic clock, ticking toward a spectacular finale. For now, we live in its golden age. The sun's journey shapes the fate of everything in our solar system. Right now, our sun is a yellow dwarf star, just the right size and brightness for life. Earth sits in the habitable zone, where liquid water can exist. The sun's stability has kept Earth's climate steady for millions of years, allowing life to thrive. While the sun has sunspots and flares, its energy output is remarkably constant. This calm has been the stage for evolution, from single-celled life to humanity. The sun is slowly getting brighter, but the change is too gradual for us to notice. One day, this brightening will have huge consequences, but for now, we enjoy a long, peaceful summer. The sun governs our seasons, weather, and the beauty of sunrise and sunset. We are lucky to live during this calm, balanced era. In about 5 billion years, the sun's core will run out of hydrogen. Fusion will stop, gravity will take over, and the core will collapse and heat up. This triggers the sun's transformation into a red giant. The outer layers will expand, and the sun will grow so large it may engulf Mercury, Venus, and possibly Earth. Its surface will cool and turn reddish-orange. The sun will become a monstrous swollen star, filling our sky. This red giant phase will last about 1 billion years, during which the sun will pulsate and lose mass through powerful stellar winds. These winds will blow away the outer layers, creating a glowing planetary nebula. At the center will be the sun's hot, collapsed core. The star that gave us life will become the agent of our world's destruction. The red giant's beauty and terror mark the sun's final act. The solar system will be forever changed. The sun's death will be both spectacular and inevitable. Long before the sun becomes a red giant, life on Earth will vanish. The sun's slow brightening will heat our planet, triggering a runaway greenhouse effect. Oceans will evaporate, and Earth will become a scorching, lifeless desert. All life will be extinguished, and the planet will be baked and cracked. This will happen in about 1 billion years. If Earth survives the red giant phase, it will be a molten, unrecognizable world. Any trace of civilization will be erased by the sun's intense heat. The only hope for humanity would be to leave Earth and seek a new home elsewhere. Perhaps we'd move to the outer solar system or even another star. The end of Earth is certain, but humanity's story could continue. Our instinct for survival may carry us beyond our dying world. The sun's changes will force us to look to the stars. After the sun sheds its outer layers, only its hot, dense core remains, a white dwarf. This remnant is about the size of Earth but contains half the sun's mass. A teaspoon of white dwarf material would weigh several tons. It's one of the densest objects in the universe. The white dwarf will glow brilliantly at first, but with no fusion, it will slowly cool and fade. Over trillions of years, it will become a cold, dark black dwarf. The solar system will become a graveyard of frozen worlds orbiting a dead star. If Earth survives, it will be a frozen dark rock. The sun's final legacy will be silence and cold. The great engine of our solar system will fall quiet. The story of our star ends in darkness. Could the sun die early from a cosmic accident? The universe is violent, but such events are extremely unlikely. A rogue star or black hole passing close enough to disrupt the sun is almost impossible. Space is vast, and our solar system is in a quiet, stable part of the galaxy. Some fear the sun could explode as a supernova, but it's not massive enough for that fate. Our sun will not explode. Its death will be slow and gentle. The greatest dangers to humanity are not cosmic, but from our own actions on Earth. The sun is one of the most reliable parts of our lives. It will continue its steady existence for billions of years. We can count on it to rise every morning and provide energy for life. Its long-term fate is sealed, but its short-term stability is certain. The sun's calm presence is a gift. We can rest easy under its light. Humanity's time on Earth is just a blink in the sun's long life. All our history has unfolded during this brief, golden moment. The sun's light connects us to the universe, a daily reminder of our cosmic origins. We are made from elements forged in ancient stars. The sun's eventual death is far in the future, but it teaches us perspective. Nothing is permanent, not even the stars. We should cherish our time in the sunlight. Every sunrise is a gift, a chance to appreciate the journey of light across space. For a brief moment, we are alive and aware, bathed in the sun's glow. The sun's story is our story, and that is truly wonderful.